1917 marked a pivotal moment for American military industry as the legendary automotive magnate Henry Ford received a critical assignment from the United States government, one that held the potential to alter the course of the Great War in Europe. The demand was clear: a lightweight tank capable of mass production on an assembly line reminiscent of the iconic Model T, which had already flooded the roads of America. Engineers at Ford's company faced the daunting task of designing a vehicle that combined the simplicity of manufacturing, the reliability of automotive components, and the combat effectiveness of European tanks. At first glance, the challenge appeared manageable. Ford had already demonstrated an unparalleled ability to produce complex machinery faster and cheaper than his competitors. However, the requirements for wartime vehicles necessitated a radically different approach. The French light tank, the Renault FT-17, had sparked a revolution in tank design, showcasing to military leaders across Europe what a modern combat vehicle should embody. Its layout, featuring a mounted weapon, a rotating turret, a rear engine, and a front control compartment, became a blueprint for innovation. American specialists meticulously studied the blueprints and descriptions of this French marvel, eager to uncover the secrets behind its battlefield success. Inspired by the Renault, Ford's engineers embarked on the ambitious quest to create an American tank that would surpass its European counterpart in both production technology and manufacturing cost. The design team, fueled by unprecedented enthusiasm, understood they were not merely replicating the French model. They were tasked with crafting a fundamentally new American tank. The primary directive was to maximize the use of automotive components already in mass production at Ford's factories. This strategy promised to significantly lower the cost of each vehicle while enabling the assembly line to churn out hundreds per month. Ford envisioned inundating European battlefields with his tanks, just as his cars had dominated American roads, creating a veritable tidal wave of armored might that would shatter enemy resistance. Early prototypes bore a resemblance to their French counterparts, yet American engineers were determined to implement revolutionary changes that would simplify production and reduce costs. The most radical decision was the complete elimination of the turret, a feature that demanded intricate machining and precise fitting of components. Instead, a 37mm gun and a machine gun were mounted directly onto the frontal armor of the hull, transforming the tank into something akin to a self-propelled artillery unit. To ensure situational awareness, designers included a small mushroom-shaped observation dome, allowing the commander to survey the battlefield from a vantage point that was both practical and innovative. The design of the American tank was a marvel of originality, yet it raised numerous questions among military experts. Engineers at Ford integrated not one but two engines into the transmission compartment, positioned parallel to each other. Each engine boasted its own gearbox, independently driving the tracks on one side of the vehicle. While this approach appeared logical, utilizing serial automotive components, it led to significant synchronization issues between the two power units. The driver had to vigilantly monitor the revolutions of both engines to ensure the tank moved in a straight line. If one engine failed, the vehicle could only rotate in place, leaving it vulnerable and immobile. The tank's chassis was bolstered by the application of reliable automotive solutions. 6 road wheels on each side were connected in 2 bogies, suspended on semi-elliptical springs attached to a longitudinal beam. This setup provided a commendable smoothness over rough terrain. Above the wheels, 2 support rollers prevented the tracks from sagging, ensuring optimal performance. The drive wheel, located at the rear, featured teeth designed to grip the track. It significantly outmatched the guiding wheel in diameter, extending beyond the vehicle's body, reminiscent of its French prototype. This entire construction aimed to grant the tank excellent mobility and reliability in combat scenarios. Inside the front section of the hull, a crew of 2 occupied the vehicle in surprisingly comfortable conditions. The driver and the commander, who also served as the gunner, sat side by side, managing the tank's movement and firing its weaponry. The absence of a turret restricted the tank's flexibility in battle, effectively rendering it a type of light tank with a limited firing arc. By the spring of 1917, Ford's factories ramped up efforts to create the first prototype of a 3-ton tank, intended as America's response to European armored vehicles. The military allocated substantial funds for development, aiming to produce a ready combat machine by summer. This urgency stemmed from the desire to dispatch the first shipments of tanks to the front lines before the onset of autumn's muddy conditions. Engineers worked tirelessly, striving to harmonize automotive components with the demands of armor and armament. Each day brought forth new technical challenges that required immediate resolution. As time relentlessly marched on, and the war in Europe showed no signs of waiting for American tank builders. The primary concern for the designers became the synchronization of the 2 independent power units, each controlled separately. This complexity tested the limits of engineering ingenuity, as the need for a reliable and effective combat vehicle grew ever more pressing. The quest for a solution was not merely a matter of mechanics. It was a race against time, a desperate attempt to ensure that American forces would not be left behind in the relentless march of warfare. The echoes of distant battles loomed large, urging the engineers to find a resolution that could transform their ambitious vision into a tangible reality. The ambitious vision of a dual-engine tank, equipped with its own transmission system, promised a leap in military technology. In theory, it appeared elegantly simple, allowing the integration of standard automotive engines with minimal modifications. Yet, reality told a different story. The driver found himself juggling 2 gear levers, 2 clutch pedals, and constantly monitoring the gauges of both engines. Even the slightest discrepancy in engine revolutions sent the tank veering off course, transforming a simple maneuver into a grueling test of skill and precision. Military testers quickly dismissed this design, demanding a comprehensive overhaul. Months slipped by as engineers toiled to refine the control system, wrestling with the challenge of balancing production simplicity with user-friendliness. They experimented with various linkages between the 2 transmissions, installing additional mechanical synchronizers and adjusting gear ratios. Each modification necessitated a fresh round of testing, unearthing new flaws in the design. As time passed without a viable prototype, anxiety mounted within military circles. Generals, impatient for results, threatened to shift the contract to other manufacturers, who were eager to offer their own versions of light tanks based on foreign models. The armor of the tank became another contentious point between designers and military clients. The engineers advocated for minimal armor thickness to reduce weight and allow for less powerful, hence cheaper, engines. In stark contrast, military officials demanded enhanced protection, capable of withstanding enemy machine gun fire at all combat ranges. This impasse forced the teams to seek a middle ground. Ultimately, they increased the thickness of the frontal plates to 16 millimeters and the rear to 13 millimeters. This armor could shield the crew from standard rifle rounds and shrapnel, yet it remained vulnerable to the larger caliber bullets that could easily penetrate. Compounding these challenges was the absence of a rotating turret, which severely limited the placement of weaponry and ammunition. The 37mm gun was rigidly fixed to the frontal armor, offering restricted angles of elevation and traverse. Engaging targets positioned to the side required the entire tank to pivot, exposing it to enemy fire during the maneuver. A machine gun was mounted beside the cannon, but its field of fire was even more constricted. Ammunition storage became a logistical nightmare within the cramped confines of the hull. The shells for the gun had to be arranged carefully to avoid hindering the crew's movements, while simultaneously posing a heightened risk should an enemy shell find its mark. The summer months of 1917 were marked by a whirlwind of activity and relentless determination, as engineers sought to navigate the tumultuous waters of military expectations and technological limitations. Every hour spent in the workshop brought them closer to a solution, yet the path remained fraught with obstacles, each demanding innovative thinking and steadfast resolve. The quest for a functional tank was not merely about engineering. It was a race against time and the looming specter of competition, a battle for survival in the ever-evolving theater of war. Engineers tirelessly labored to rectify the shortcomings of the tank's design. They meticulously reworked components, tested new materials for the tracks, and experimented with suspension systems. Each modification necessitated the creation of new parts, their installation, and yet another round of grueling tests. The factory floors operated around the clock, striving to meet the tight deadlines imposed by the military. Yet, the harsh reality proved far more daunting than any plan could have anticipated, and a ready prototype remained elusive. As frustration mounted within the military ranks, competitors of Ford began showcasing their own advancements, drawing on licensed copies of French and British tanks. With the onset of winter, a new wave of challenges emerged for the tank developers. Frigid temperatures exposed critical issues with engine startups. The cooling system needed refinement, while lubricants thickened in the cold, hindering the operation of essential mechanisms. Specialized procedures for preparing the vehicle for cold weather starts had to be developed, further complicating its usability. Military testers voiced their concerns, highlighting that the tank demanded excessive time for maintenance and preparation before combat, especially when compared to its European counterparts. These critiques necessitated further revisions, pushing completion dates further away. Only by the middle of 1918 did Ford's engineers finally manage to construct the first fully equipped prototype, officially designated as the Fort 3-tonner. This machine weighed approximately 3 tons, stretched just over 4 meters in length, and stood around 2 meters tall. Powered by 2 gasoline engines with a combined output of 45 horsepower, the tank was designed to achieve a maximum speed of around 13 kilometers per hour on highways and 6 kilometers per hour across rough terrain. With a range of about 50 kilometers, it was deemed sufficient for operations over limited sections of the front. Factory tests for the prototype commenced in June of 1918 at Ford's facility in Detroit. A delegation arrived in full force to witness the culmination of months of labor by American engineers. As the tank rolled out of the assembly bay, it was met with intense scrutiny from high-ranking officers. The unusual appearance of the vehicle immediately caught their attention. The absence of a turret sparked mixed reactions among military specialists. Some viewed it as a sensible simplification of the design, while others saw it as a significant tactical flaw. The bulbous observation dome resembled more of a submarine feature than that of a tank. The driver struggled to ignite both engines, which roared to life at uneven revolutions, creating a distinctive and disconcerting vibration throughout the chassis. As the tank took its first tentative steps forward, the primary flaw of its design became glaringly apparent. The challenges faced during development had only begun to unfold, setting the stage for a fierce battle between ambition and reality on the front line of innovation. The tank veered off its straight course, demanding constant adjustments from the driver. As the mechanic attempted to turn the vehicle left, he had to reduce the power of the left engine while simultaneously increasing the right, an intricate task requiring the coordination of 4 controls at once. Observing this, military officials shook their heads, realizing that training drivers for such a complex machine would take considerably longer than for a conventional tank with a single engine. Testing on the proving grounds exposed a multitude of design flaws that had eluded detection during initial assessments. The tracks frequently derailed in uneven terrain, particularly on tight turns, where the tank's stability was compromised. The semi-elliptical leaf spring suspension provided a degree of ride comfort, yet traversing trenches and craters caused the vehicle to sway violently, rendering accurate shooting nearly impossible. Debris often clogged the drive wheels at the rear, leading to slippage of the tracks. The large diameter guide wheels, protruding beyond the hull, proved to be highly vulnerable to damage upon contact with obstacles. Firing the 37mm gun revealed another critical issue. The rigid mounting of the weapon forced the driver to almost guess the precise moment when the tank aligned with its target to take a shot. Limited angles of elevation made it nearly impossible to hit targets positioned to the side or rear, necessitating a complete turn of the tank to engage an enemy flank, a maneuver that consumed precious time and exposed their position. The machine gun performed slightly better, yet its effectiveness was hampered by a narrow firing arc. Within the cramped interior, a cacophony erupted from the dual engines and the recoil of the armament, while the powder gases struggled to escape through the scant ventilation openings. A military commission meticulously documented the discovered shortcomings, but also acknowledged the positive aspects of the design. The use of standardized automotive components indeed simplified production and reduced costs. The armored protection met the requirements for light tanks of the era, and while the chassis had its flaws, it still offered acceptable mobility. The project's primary advantage lay in the potential for mass production, using existing Ford manufacturing capabilities. Den Reforth assured military officials that once the identified issues were rectified, his factories could produce up to 100 tanks each month, providing the American Army with a sufficient supply of armored vehicles. As August drew to a close, efforts shifted toward refining the design based on the military commission's feedback. Engineers worked diligently to enhance the tank's capabilities, striving to transform it into a formidable asset on the battlefield. Each modification brought them closer to a machine that could withstand the rigors of combat while delivering the firepower needed to secure victory. The relentless pursuit of innovation shaped the landscape of warfare, as engineers toiled diligently to enhance the tanks that would soon become the backbone of the American military. The tracks were meticulously reinforced, while the engine management system underwent a significant modernization. Improvements were made to the ventilation of the combat compartment, ensuring that those inside would have a fighting chance in the heat of battle. As the leading wheels received additional armor plating, more reliable sighting devices for both the cannon and machine gun were installed. Each enhancement demanded rigorous testing and scrutiny, revealing even the slightest imperfections that needed addressing. While prototypes were fine-tuned, factories ramped up preparations for mass production. Equipment was procured, workers trained, and assembly technology meticulously outlined. The military department greenlit the plan for the first batch of tanks to be delivered to the troops by year's end. Ford secured a substantial government contract, along with guarantees for the program's funding. Factories sprang to life, producing armored plates, assembling engine and transmission sets, and fabricating tracks. All signs pointed toward the American Army's impending acquisition of its first domestically produced mass tank. Yet the harsh realities of war cast a long shadow over these ambitions. September brought encouraging news from the Western Front as Allied forces launched a successful counteroffensive, breaking through the German defenses. American expeditionary forces, actively engaged in battle, relied on French Renault tanks. The successes of armored warfare intensified the military command's urgency to procure their own tanks as swiftly as possible. By this time, Ford had managed to produce several pre-production models, increasing the total number of constructed machines to 50. These tanks underwent rigorous testing across various proving grounds, all in preparation for deployment to Europe. October unfolded as a month of decisive events on the battlefields of the Great War. Germany was losing position after position, its allies capitulating one by one and signing separate armistices. It became glaringly apparent that the end of the war was near, and this news sparked a wave of panic within the Ford factories. The pace of tank production slowed, as workers understood the grim reality. If the war ended before the tanks were ready, the entire project would be rendered meaningless. On the 11th of November, 1918, a date that would forever alter the course of American tank manufacturing, the armistice between the Allies and Germany came into effect at 11 o'clock in the morning, Paris time, putting an end to 4 years of brutal conflict. News of the cessation of hostilities reached the Ford factory on the same day, provoking mixed reactions among the workers and engineers. On one hand, there was jubilance at the conclusion of a horrific slaughter that had claimed millions of lives. Yet, on the other hand, many grappled with the sobering realization that months of intense labor on the tank had culminated in what now seemed an exercise in futility. The dreams of a new armored force, so carefully crafted and planned, hung in the balance, overshadowed by the sudden and unexpected dawn of peace. As the echoes of war began to fade into the distance, the military department swiftly slashed its order from the manufacturer, reducing it to a mere 15 tanks before questioning the very viability of continuing the program. By the time a ceasefire was declared, the factory floors bore witness to 10 nearly completed tanks, each in varying stages of assembly. An additional 5 machines awaited the installation of armaments and final adjustments to their systems. General Ford, ever the optimist, insisted on completing the work on these 15 prototypes, citing the critical need for technological refinement and training for troops on domestic armored vehicles. After lengthy deliberations, military officials reluctantly agreed to accept the finished machines. Yet they firmly rejected any further orders. Thus, a grand vision of mass-producing tanks for the American Army dwindled to a mere 15 units, most of which remained incomplete. December arrived, shrouded in cold and snow, yet the factory's operations trudged along at a sluggish pace. Workers, acutely aware that the conclusion of this order might spell the end of their jobs, were in no rush to finalize the assembly of the tanks. Military inspections also lagged, with tests postponed until spring. The atmosphere within the workshops was heavy with despair. Instead of the jubilation associated with mass production, there lingered a bitter taste of lost opportunity. General Ford himself made visits to the factory, striving to uplift the spirits of the workforce, but even his renowned optimism struggled against the harsh realities of a post-war landscape. By the spring of 1919, all 15 tanks finally underwent acceptance trials and were officially handed over to the military. Of these, only 10 were deemed fully combat-ready and dispatched to training units for tank crews. The remaining 5 languished in storage, repurposed as sources of spare parts and subjects for technical experimentation. Military engineers continued to scrutinize the tank's design, eager to discern which innovations could be harnessed for future projects. A particular point of interest lay in the dual-engine power system, which theoretically offered enhanced maneuverability even if one engine failed. The 10 operational tanks found their homes across various military bases throughout the United States. Tank crews, trained on the French models during the war, approached the American design with a mixture of curiosity and disbelief. The absence of a rotating turret struck them as an anachronism, a regression to the earliest British diamond-shaped tanks. Managing 2 independent engines demanded a unique skill set and unwavering focus. Many instructors openly criticized the design, drawing unfavorable comparisons to contemporary French models. Yet, orders were orders, and the soldiers diligently adapted to their new machinery, navigating the complexities of a bygone era. The remnants of ambition and innovation lingered in the air, a poignant reminder of what could have been in the relentless march of history. The summer exercises unveiled the glaring weaknesses of the American tank, revealing its vulnerabilities in conditions closely resembling actual combat. A limited firing sector rendered the machine susceptible to flanking attacks from an imagined enemy. The inability to fire on the move due to intense shaking transformed the tank into a stationary artillery point, a sitting duck in a dynamic battlefield. Frequent track breakdowns and synchronization issues with the engines meant that, out of every 10 tanks in operation, only 6 or 7 were typically battle-ready. Mechanics found themselves spending more time on repairs than crews did on training, a troubling reality that undermined readiness. Fuel consumption exceeded projections, while operational range fell short of what was promised in technical documentation. As autumn approached, military command made the pivotal decision to phase out Ford tanks, opting instead for American Renaults, whose production had been established at the factories of Vaud. The French design had proven its effectiveness in the brutal realities of the Great War, while Ford's creation remained merely an experimental prototype, a relic of an era that had passed. Military engineers compiled comprehensive reports detailing the design's shortcomings, particularly criticizing the impracticality of the dual-engine scheme and the rigid weapon mounting. These findings laid the groundwork for the requirements of future American tanks, which were now expected to integrate the lessons learned from the global conflict. 1920 marked the final full year of service for Ford tanks within the American Army. These machines were relegated to demonstration purposes during military parades and exhibitions, captivating the public's imagination with their unusual design. Yet military specialists had already dismissed them as lacking any practical value. A few tanks were repurposed for technical schools, serving as educational tools for students learning the fundamentals of tank construction. One specimen even made its way to an industrial exhibition in Chicago, showcased as a testament to American engineering during the Great War. By 1921, the majority of these vehicles had succumbed to wear and tear, their engines and running gear rendered inoperative. Spare parts were no longer produced, and existing stocks dwindled rapidly. The military establishment saw little sense in investing funds to repair aging tanks when the army was acquiring modern machines of French design. A handful of tanks remained for some time, languishing in the open air of military bases, slowly rusting under the relentless assault of rain and snow. The year 1923 heralded the beginning of a sweeping rearmament program for American armored units. The military command reached a definitive conclusion. Standardization of armored vehicles based on the proven French Renault design was essential. By this time, the Vaud factories had established a reliable production line for licensed copies, which were designated as M1917. As the American Army turned the page on its tank history, it embraced a future built on lessons learned and innovations forged in the crucible of war, leaving behind the relics of a bygone era. These machines surpassed Ford's tanks in every conceivable way. With their rotating turrets and a single, reliable engine, they boasted a well-engineered chassis that had been meticulously refined. Yet, as the dust settled on the battlefields of the early 20th century, the last surviving examples of the 3-ton tank were systematically sent to military depots, awaiting a fate that offered no glory. The mid-20th century marked the definitive end of Ford's venture into tank manufacturing, as all 15 units produced were officially decommissioned and removed from the Army's inventory. Most of these tanks were reduced to scrap metal, their armored plates melted down, while the engines and some chassis components found new life in civilian machinery. A handful of tank hulls were repurposed as targets on artillery ranges, where they met their demise under the fire of training exercises. Not a single specimen graced the halls of a museum, as military historians of the time failed to recognize the intrinsic value of preserving a vehicle that never saw combat. Henry Ford never revisited the idea of tank production, channeling his efforts instead into automobiles and other civilian technologies. The experience of creating armored vehicles revealed the necessity for a fundamentally different approach to military machinery compared to mass automobile production. The attempt to apply assembly line techniques to tank construction without accounting for the unique demands of combat resulted in a dismal failure. The saga of the 3-ton tank serves as a poignant lesson for future generations of American engineers, emphasizing the importance of timely development and the critical need for thorough concept validation before embarking on mass production. The tale of this remarkable tank, which arrived too late to the battlefield, resonates as a reminder of the complexities within military innovation.